Hi guys, back again. Right, this is in response to fusionchips feedback to source post, where he claims that he's got the output that would normally go to the secondary battery, the charge battery. He's able to connect that to the primary battery, the run battery. Now basically I put a post up about it and said, no, this can't possibly work, it's shorting out through the diode. And fusionchip turned around and said, prove it. Okay, here's a video. Right, here's his circuit diagram as posted on overunity.com. Right, okay. That's a little bit of a mess. Here's one that I've done exactly the same, but it's a lot easier to read. Right, okay. So, my claim is, from the capacitor, it's basically shorting out through the diode that's above the battery, and what can I say, back to the other side of the capacitor. So, fusionchip said that extra diode that he's put in is a special high voltage diode. Okay, there's nothing special about that diode at all. Okay, it's the SK3606. Right, come to the technical specs, which is here. Right, peak reverse voltage is 200 volts, forward current 15 amps, peak surge current, forward current that is 300 amps, forward voltage drop is 1.47 volts. Right, okay, well I don't have one of them to hand, and I'm really not going to be asked to go and chase one. Okay, I have used instead a superior model. Right, let's see. Okay, the one that I'm using is a BYQ 28EB. Okay, and it's the 200 model. Okay, maximum repetitive peak reverse voltage 200 volts. Compared to his, that's exactly the same. Okay. Maximum average forward rectified current per device is 10 amps. Oh well, that's less than his, but I really doubt we'll be getting anything above an amp at the most. Okay, peak forward surge current 55 amps. Reverse recovery time is 20 nanoseconds. I forgot to say this is a dual ultra-fast soft recovery rectifier. That's what it's called. It's a 3-pin chip. Basically it has 2 diodes in it, hence why it's called a rectifier. Okay, the information I've just been looking for is forward voltage drop, just to compare them. On fusionchips it's 1.47 volts, on mine it's 0.6 volts. Now that information is key here, right? Remember, I'm using effectively a diode that's 0.6 volts drop. Right, okay. this is a picture of what what I claim to be happening with fusion chip circuit. Basically, as you can see, the red line shows that the voltage, instead of feeding back to the source battery, is shorting out through his special diode. Okay, I have set up here my webcam pointing at my desk. At the moment you can see my black multimeter, which is reading 2.8, 2.9 volts. And just to get rid of the power, I've got a pair of diodes here. Right, just so it stops the circuit from overloading. Right. Also, on fusion chips circuit, he says there's a 440 UF 400 volt capacitor. They run a bit like that, as you can see. Oh, okay. That's 470, 200 volts. That one. Guess what? It's not needed. It is so not required. So we'll get rid of that. On here, I have standard Bedini circuit, which is there. Right, I have my recovery rectifier. Oops, and I've just stalled it.